Yes.
Yep, it is started.
Yeah. Okay. Just making sure. So, welcome to the robotics class one-on-one. Reason why I call it one-on-one is because this first class is going to be more like an instruction into the types of robots and everything like that, and the basic of making connections to collaborative arm. And with the next one, we're going to go more deeper into programming, motions, and other things of it. We're gonna touch a little bit of it in this class, but in this course, let me say it that way. But eventually in the next one, in the second one, it's gonna go deeper into that. So once again, let's start this. Um, what we're gonna be talking about today is just a small introduction, consistency of the characteristics of robotics, the use for robotics, the type of robots, industrial robots, basic components, and degrees of freedom. Now, robotics is nothing but the intersection of science, engineering, and technology that brought machines to life, and were called robots. Now, we as the general population has always been fascinated with robots. Either you like it or not. You would be saying that, that's stupid. I never knew it before. I never seen it before. It's just in the last years. Well, what about the E.T. movie or the Robocop movie or Terminator or Alien and everything like that? You'd be like, yeah, but those were a little bit science fiction. Again, it's the intersection of all these three departments that made our robot world possible. The newest movies too, that's Transformers, iRobot, and Iron Man. And actually, what they are really testing with is the human flying jacket. Testing to fly it. They done some test flights on it. Hopefully, will be in the market in the future, but it's probably going to cost a lot of money. So only the rich ones of us will be able to get it in the beginning. Um, as of 2005, all robots could be found back then in assembly lines. So it started to become more active with the robots in the automotive factories. That's where they use them a lot, and from 2005 and up, it started growing even more and more. And the reason why they was doing this is that um, these mechanical arms were tasked with, for example, welding and or just screwing on certain parts of cars and putting them together. And that involves today into expanding the definition of robots because nowadays they use them for exploring Earth's harshest conditions. It could be on the moon. It could be maybe just for the military and assisting the law enforcement, and even robots that assist in almost every facet of the healthcare. One good one is the tug. Later on in the presentation, we will be having a little bit on it, but that will be it. All robots have three basic things. They consist of three basic things. You have a mechanical construction. This helps the robot to complete the task in the environment of which it's designed for. They have electrical components to control the power and machinery. Otherwise, they can't do nothing. And last but not least, we do have a little programming with it. Without a set of code telling, the robot can do nothing, and it will be just another piece of metal just in a box and just sitting there doing nothing. Now, robots are being used nowadays in the manufacturing industries for assembly product lines, cars, and industrial equipment. Um, for in the logistics, they use them for shipping and packaging, and that picture is more like a glue machine and packaging and putting all together of certain lines. At home, reminding us for appointments, some chorus, and entertaining for the kids. Traveling, self-driving vehicles, trams, cars, and buses. Now in Europe, they are more, they're testing a lot with these trams and buses. They starting over here due to do certain bus, let them be driving around due to putting sensors on the road and put a plan of the road so they could follow and check in at every stop that they make. But that's something that they are definitely are working on too. Um, and in healthcare, assisting in surgeries, physical therapy, delivery of medicines, and clean linens. And that little machine on the right, down that last picture that came up, that's what they call a tug, a TUG. What it does is it has a plan in it. They download the plan in the machine, and with the scanners, sensors and scanners that they have at the different stations in the hospitals, it can deliver either it's sheets or towels or whatever they need at certain destinations, and that's or some of them they use them to deliver medicines in certain parts of the hospitals or in the areas that they're using it for, and these are the tugs for the people that don't really know what they are. Um, Types of robots. Now robots come in all types and shapes, and to officially carry out the task for which they are designed for. Um, and most of the tasks are actually tasks that we don't want to do, or that we're too lazy to do, or simply either just can't do it. In general, we do have five types of robots out there. We have the augmenting robots. Um, these are robots that either enhance the current human capabilities to replace the capabilities of a human human may have lost. Example is a prosthetic leg or exoskeletons, and that's an exoskeleton that you can see on the screen. Used to lift heavy weights, especially is helpful. A lot of the military guys have these nowadays, either if it is from the hip down for legs fractures or problems that they have with hands or things like that. Second types of robots is the teleoperated ones. These are mechanical bots controlled by humans. They usually work in extreme geographical conditions, weather or circumstances. Examples from these are human-controlled submarines used for fixing things underwater, especially pipelines, drones that used to detect landmines in the military on a battlefield, or performing surgery, as you can see on this one. Third type is the autonomous robots. They are operated independently of they operate independently of a human operator. So basically, they program. You just turn it on, and it'll just drive around and do whatever it needs to be doing. An example of this is a lot of you guys knows the Roomba, but nowadays they do advertising with a cat sitting on it and let the Roomba just clean around the house. Or the long bots, or these the ones in the picture is actually a pool cleaner. So nowadays they made them to clean pools too. So you don't even have to clean your pool nowadays. Just turn it on, put it in the water, and it'll just drive around and clean the pool. And like I said before, the tug. They use sensors to roam through the home or area that they need to be cleaning or doing their job in. Next, we got the humanoids. These humanoid robots look like or have even mimics like a human. So they mimic every human behavior, a lot of them being put in these rubber-faced robots. These robots usually perform human-like activities and are sometimes designed to look like us all the way down to the facial expressions, and they use them in certain things that are rather not set right now. Examples from these are the Boston Dynamics and the Atlas. This robot here in the picture is actually the Atlas. And last but not least is the pre-programmed robot. these robots operate in a controlled environment where they do simple monotonous tasks. They sample a mechanical arm on an automotive assembly line. What they do is just weld 10,000 of these part of doors or whatever they are in the line for a day. And reason why they do these is because they are more efficient, they are faster than the human being, and a lot of times once they programmed, fact of errors is very nihil, it's very small, because once it's go into its work area, unless it's being instructed or differently, or unless something gets in its way, it'll keep doing what it needs to be doing the whole day. And hey, they don't need no break, so they keep on going. Any questions on these points until now?
I'm good.
Yep.
Okay, cool. So like I said,
Yeah, we need the
uh-huh.
robot maintenance to do maintenance for robots.
Do you really want that, Peter? So we would all not have jobs.
All of those will be sitting and watching it. So, like I said, I sent it a little link to you guys. It's not much. I think it's still only 10 questions because I wasn't allowed to do more than that for the free thing. So, if you feel like it, you can do it. If not, hey, I'm happy with that too. There's a lot of buzz these days in the manufacturing sector about robots and how they can help manufacturers solve their problems and challenges. Nowadays, every day, everybody is into improving productivity and doing this in less time. Now, for the rest of this course, we're going to go further with the pre-programmed robots. To be more specific, the industrial robots. When it comes to industrial robots, these can be divided into two major types. Two major types of robots. We are talking about the mobile industrial robots and the stationary industrial robots. So just to give a little information about the mobile before we keep on going with the stationary ones, mobile robots have a wide variety of structures and setups. They have abilities of movement. They have different abilities of movement, from a limited movement in a defined space, or to a global movement through a whole facility. And why is that? It's because they're mobile. The name says it all. What are considered mobile robots? We got three general main group for these, and those are the wheeled robots, and these are particularly most of the time used as in warehouses. And if I'm not wrong, Amazon got one part of these. When they moving their pallets, these drive underneath the pallets and then take it along in the warehouse. Then we got the leg robots. They are doing a lot of tests with these. I don't know to do what, but hey, they are. I think in certain areas that are difficult to get to, they will be handy to get in with, but it takes a long time for them to walk around then instead of having wheels. So, my opinion, the wheeled ones will be better mobile than these. Maybe in the further future, they will be faster with these. And then, as many of you guys know already, the drones. They are becoming more popular in the manufacturing. Depending on the type of mobile robot, they are able to travel to different areas of the facilities. And drones are the only ones in this group, actually, that still have a limited payload, but can be used to still move parts and materials. And they are looking into now to use drones to transport medical parts. When I would say medical organs from one hospital to another. I don't know how they're going to do it with all the planes. They're probably going to put a certain area that they are allowed to fly in. But they are working on that, and besides that, they're even trying to make drone taxis nowadays. Hey, who's going to pay for that? I don't know. So, yes. The types of mobile robots that comes in the industry are the tow vehicle ones. You got these ones and the ones that I just said that Amazon uses that go underneath them. We got the unit load carrier. They use these too. And cart vehicle. You put the cart on it and it just it just takes the whole thing along if it is for a heavier and bigger load. And last but not least, excuse me, you got the forklift vehicles. As you can see it, those are considered robots too, because a lot of times, hey, it's a program that you do, and they got to be moving things around too in a warehouse. Any questions until now? I guess that's no.
Nope. Nope.
Now, moving to stationary robots. These are robots that are anchored to the ground or to a structure by some sort of base that limits their movements. They're always working from a fixed position, though nowadays some of them are put on a platform that can move to, so they can get a little bit of mobilization too. And put on a track so they can follow that track and do things. And majority of the plants nowadays do this if they gotta travel from one line to another and there's a little distance between it, and that's why they put the wheels underneath it, the platform with wheels underneath it, and let these follow a sensor line to get to the other line to do what they have to do. If it is packaging, getting another product, or pass it to another robot, or whatever that they have in store for it to do. They often feature a robotic arm. They often feature a robotic arm that performs a variety of options. They control the position and orientation of an end effector to perform their tasks. Now, what is an end effector? An end effector is nothing but the laser point that they use to weld something, or the gripper that they use to grip something, a product, to grab a product or something on the line to put it in a package. It's just that end part of the robot that really does the last part of the movement that the robot needs to be doing. And they do not have the ability to move their body as a whole, but it's more and stepwise, and you'll see it too later down the road when we do a little bit of the programming and I do a little introduction to it. You will see that it's kind of like the PLC. It just reads it line by line and be like, okay, cool, now you do this, go to that, do that, and that's how they do it. That's why they cannot move all the limbs at the same time, because it's going to be a crash for them. Stationary robots are used often for moving materials from one place to another within a small environment, install or uninstall parts, and generally conduct the same process repeatedly with a high accuracy. That's why they use them nowadays, because they can substitute the human being and not give them breaks. Yeah. Yay! There are two types of stationary robots, and it keeps on going. We got the first one is the serial robot arm. This is the most common type of robot arm that is used in the industry. They are made of a series of links that are connected, in other words, joints, from the base to the robot, to the end effector of the robot. Serial robots arms typically have 6 degrees of freedom, actually 3 to 6 degrees of freedom. Each joint can move independently of the other. And then in the second one, we got the parallel robot arms. Usually have 3 to 6 linear actuators that work together to connect the robot base to the end effector and control its movement. Unlike the serial robot's arms, all the joints in the parallel robot arm must move together in order to function. So with other words, you guys can see my mouse, right? So in other words, this is the base in this case. So with a serial robot, this is called the base. With a parallel robot, this is your base. and this is your end effector. And in a serial, the end effector will be connected here. So what they do is these gotta move together for the end effector to be able to do what it needs to be doing. They are significantly more rigid than the serial robot arms, and that's why they can be used in more heavier stuff and areas that needs better and stronger structure sometimes. Now, there are several types of stationary robots. The reason why I'm doing the stationary robots is because this is what we're going to keep doing, and eventually it will roll into the collaborative arm. We have got the articulated robot. These are serial robots that most likely resemble the human arm. As you can see, it's got a base, which is actually our shoulder, and then this is considered the arm then. They have at least 3 joints. They are ideal to use for assembly, welding, and spray painting applications. Then we got the Cartesian robots. Serial robots with these are serial too. They are very rigid structure. The feature actually 3 prismatic joints that only move linearly. So these cannot move like the articulate ones. Because these are more rough built, they just move in 90 degrees or just from left to right. They are extremely precise though, because of their rigid structure and contain the joint movements. Best used for assembly, welding to, and material handling applications. And nowadays they use these kind of robots, you can say, for 3D printing too, for that laser point to be printing what you want out of it. Third, we got a combination. Those are the cylinder or the spherical robots. Now the cylinder ones have combination of revolute and prismatic joints. The axes are shaped like a cylinder, but the spherical ones, the axes are shaped in a spirit. So they're not cylinder, they're just more like a triangle sometimes. It depends when you see it. They have them in different models though. These types of robots are defined by their coordinate system, and they may include other types of robot arms on them, and that you can see because of at the end of it, here you can still put one of the connectors that you can put on a regular arm. You can connect them if they have adjustment parts on it to put on. Efficiently in round workspaces for the cylindrical ones, and are best used for assembly, machine tending, and welding. Then we got the SCARA. You'd be like, okay, what's the SCARA standing for? The SCARA is standing for, give me 1 second, Selective Compliance Assembly Robot Arms. It is a serial robot too, featuring an arm with 2 joints and 1 prismatic joint. It has 4 axes of movement and moves through X, Y, and Z, but along with a 4 theta Z coordinate, and that one is actually this X right here, because that one can go in circular and left and right too, and it has its own drive over there. They often used for pickup and place assembly and material handling applications. And last but not least, we have got the Delta. And they are the stationary of the group, stationary robots. And like I say, they have 3 robotic arms connected to the base. They're gaining popularity because of their high speed, because they move a lot faster though. packaging and pick and place abilities. Extremely accurate due to their parallel structure, and they are used for speed packing, speed pick and place, and packaging. Now, with that being said, now you got a little bit of a sight of the different robots that are there, because a lot of people say sometimes that, okay, cool, we got robots, let's work with robots, but you got to know which one you got to put in a system and why you're going to be using, what you're going to be using it for, so you can make the right choice of robots that you're going to be using for the line that you're going to be working with, or for the product that you're going to be dealing with. Now we're getting more into the direction of the collaborative, and we're going to go to the basic components of the industrial robots. Now, these robots have about 5 things as basic components. The first one is your input device. Your input device is how engineer or operator interacts with the controller. They usually consist of buttons, keys, and some screen that displays actually the entered information that you put in the system for the robot to go do. They can be a remote control with just a few buttons, or more complex and be a keyboard. Nowadays, even a phone. Most common form of input device is actually what you see here on the screen, and they call them a teach pendant. This teach pendant allows a precise control of the robot and has a simple and straightforward setup. And as you can see the movements that you can do with the robot: up, down, left, right, half circle, or certain movements, which we're going to talk about too. You can see the X, Y, and Z, the coordinates where the arm is positioned. And these are speed, or the wrists, or the certain parts of the robot that are moving at that point. We will go further down into that once we do the programming and those kind of things. Next, we got a controller. These are information processing devices that initiates the robot movements. They translate information from an input device, keyboard, or a teach pendant, and then carry it out to program responses. So we all know it's just a control box. Then we got the motors and drives actually. Make up a robot's drives system that enables the robot to move. Either electrical, or nowadays either hydraulics. Motors can be used to provide the force that a robot needs to move things. But hydraulic ones are generally less precise than the electric ones. Then you got the base and the body. These are the main structure, foundations, and support for the robot. The base is where the robot is secure to the ground, or a fixture where it's hanging from. And the body is actually the casing and provides structural support for the other components that are on the robot, which other components, I mean sensors and other things that you can put on it. And last but not least, the sensor. These provide feedback to the robot system in order to allow the robot to assess environmental conditions or part quality and adjust its behavior based on the feedback that it's getting. Sensors can be contact or non-contact. They can be located on the robot itself or from a remote location. These can be used to detect a subject by touching, proximity, or the vision of it. And with these, we're going to do a little in the last part of the presentation. You will see this too. Degrees of freedom. What are degrees of freedom, you may say? Oh, yes. Now, they're nothing more than joints. They specific defined modes in which a mechanical device or system can move in a 3D space. Sorry for that. The joints of the robots are sometimes referred to as axes. But in the robot world, it is referred to a place on the robot where it is capable of moving rather than an axis in a coordinate system. Because a lot of people get it messed up. Industrial robots have various axis configurations. An industrial robot will typically have 3 to 6 axes, and the more axes they have, the more flexible they are, and the better they operate. Now, in the next page, I will have a picture of an arm, and there's a lot of text coming to it, but I will just show you certain things, and it will be more clear. Now, the first X is down on the button, and that's the base. Oh, sorry. This gives the robot the opportunity to turn 360 degrees of a center point. Actually, that's the first X. That's all what it do. If you gotta go to the left, to the right, all the way to the back, and it will turn 360 degrees with no problem. And that's the job of the axis number 1. Then we have axis number 2. This allows the arm, it is here, that's the axis number 2. This allows the arm to go to the front and the back. So now you have the base turning around, and the axis number 2 goes to the front and the back. And that way you can go further to the front or further to the back if you need to get something. Axis number 3 is actually your elbow over here, and that's an extend on your axis number 2, because it allows you to go when it opens. Actually, the whole arm will open for it to go and extend in the vertical reach, and goes either if it is further for reaching, or if it is higher or lower reach. That's the part and the job of the axis number 3. Then we have the axis number 4, which they call wrist number 1 actually, in conjunction with axis number 5. It aids in the positioning of the end effector. So it helps, and I have a video too with it, so we'll see that. It will help you for reaching, and a lot of times you gotta move a little bit to the left, or turn a little bit degrees, maybe 10 more degrees to the left, or 10 more degrees up, and that is what the axis number 4 will help you do. It's getting more precise for the end effector to reach its end destination. Axis number 5. This is actually the part that allows the wrist to go up and down. So this one goes either that way and that way. It don't matter where you at. It just swings either up and down, or it can go left and right. It depends on which degree and which angle you have. And then last but not least is the wrist number 3, which is actually where you can put a gripper on it it will work as a twisting motion for your gripper. So that will help you either open or close your gripper, turn it around 360 degrees for it to be more flexible to get what it needs to be getting. Now, this is just the general axis explanation for the general robots. Now, you always got the other brands that name things different, and you will be having it is funny. We have the Moto Man that says, you know what, we're not going to use axis, we're going to use letter. We're going to put the letter in front of it, and we're just going to call them S, L, R, U, B, and T axis, which is the same thing as the axis 1, 2 through 6. And Fanuc came along. Fanuc says, you know what, everybody got their own thing. I'll put my own thing too. We're going to call them J1, J2 until J6. So it depends what robot you're working with. Then you got different names for calling it. Now, like I said, if you guys don't have any questions, I'm going to go through 2 little videos that I got, and then we'll be done with it. Any questions?
Nope.
Yeah, I think probably we missed that because the when we're building robots, so we have to follow it should like a certain regulations rules because
Hmm.
uh, so it's really important because that should be a security guard covering the territory where a robot can reach.
Yep.
So yeah the special the separate like safety controller which controlling the security zone around the robot. So um, it's like in our day, so it's important for this type of robot with arms and booms because.
Yep.
For
And
movable robot, probably not yet, but all the things can hurt people, so should be secure.
yes, that is true, and that is one of the things that will come in the second video that I have, and
Okay.
I will go more into it into the programming part too in the next class.
All right. Yeah. Sorry
Yes.
about this.
No, no, no. You good. You good. You good. I mean, hey, if I didn't cover it, hey, it's just always good to have. Okay.
Hmm.
So let's take a look at this video.
All
Video
right.
number one. I will in between I will pause it because making this video, I kind of had to edit and make certain things to be clickable for myself and then film myself. So have a little patience with that. It's only like you see 4 minutes and 39 seconds, but it might take a little longer because I'll be talking in between. In this video, we will be getting a short introduction again, just showing you the 6 axis, and just for you to see. And as you can see, the arm can turn 306 degrees. Now, you got the base, the shoulder, that's X number 2, the elbow, that's X number 3, wrist 1, that's X number 4, X number 5, and wrist 3 is where you can plug that end effector on, but that can turn 360 degrees too. Now I choose to do universal because unis are more clear to work with in my opinion, and the teaching pendant is very friendly. So that is the reason why I chose the universal arms, collaborative arms. Okay, so that's actually the axis of the robot. Now we're going to go to the control box. Now, when you open the control box, let's pause. When you open the control box, I don't know. Wait, is this better? I think this is better. When you open the control box, you can find the motherboard, the SD card, and the safety control board. Now, the safety control board handles all the inputs and outputs from the control box and connectivity to the other equipment, such as the safety devices, sensors, machine interfaces, and push buttons. The dedicated redundant safety input is for connections of external emergency stop and safeguard only. So that will be this one. It will light up orange. I don't know if you guys is going to be able to do it. So this is the complete board for all the inputs and outputs. But then the dedicated redundant safety input is actually only that part. Yeah, you can see you can see another mouse going. So that's my mouse going when I was doing it. The 16 yellow connectors can be used for both general purpose, those are these, or can also be configured to use as a redundant safety input and output. The 16 gray connectors are digital inputs and outputs, or for general purpose such as sensors and conveyors. The green connectors are actually analog signals, so that's these. And the safety control board also contains a microchip on it, and it has that microchip PC with a fast computing power, and it has Ethernet connection and USB connectivity on it. The SD card that it has on it contains all software, including the Linux operating system and the universal robot patent programming called Polyscope. That's what the program is called that they use on the teaching pendant. and the program created by the user, of course, that you be saving while you programming. Now let's go to the teaching pendant. First thing you gotta do is to power up the teaching pendant. It's nothing difficult to do it. It looks like this for most of the universal late versions. They look at the same thing. How you power it is just click that button on the top, and it will power up your pendant. It will take a couple of seconds because it needs to load things up. After powering up the pendant, you need to initialize your robot. And to do so, let it open. To initialize your robot, you will have a red button down here, and you will have to click it and to go to the next screen where you can initialize your robot. Now, as you can see on this screen, you can see that the robot is actually powered off. But what we are going to do right now is we're gonna boot it up, and then after booting it up, we have to release the brakes too. So the first thing you can do to boot it up is press the on button, and as you can see, it powered it up and booted up, but then it tells you that the robot is active, but the brakes are not released yet. So even if you want to do something, the robot won't move because it's jammed. It's just break down. And you can see too that the system is yellow. It's not green, so you can't do nothing with it. So to do so, you click again on the start button, and that will make the whole robot ready to go. Now that you have done that, you can exit this screen, and then we're going to take a look at the programming of the robot. How do you do the first basic program interface with the robot? It's going to go just a couple of basic things, and just for you to get a little inside of it, and then we're going to go to the next video, and that one won't be that long yet. So let's take a look at that. Now that you open it, as you can see, highlighted orange center point, the middle pane is called the program tree. That's the robot program tree. And a lot of times when you make a new program, this will be the name of your program, of your robot, or however you want to call it. And everything that you put for the programming will come underneath this. The commands are executed sequentially, just like I said, it just reads it one-on-one and keep on going down until when that step is finished, then it's going to go to the next one. And that's how it do. It can never do 2 steps at a time, because otherwise the robot don't know anymore what to do, and it'll block itself and it'll stand still. So they're robots, but at the same time, they're not that smart. In the left thing, you will find the options commands. These are options that you can choose from when you're programming. So let's add a movement to the robot right now. And to do so, you click on the move button. And once you click on the move button, you will see that it will create a motion and a waypoint. Now, as you can see, it created a motion, and that motion is called Move J. Now, you will say, why Move J? What is it with Move J? With these robots, there are a couple of motions that they use to program them. And Move J is just one of the type of motions that they have. They have the basic motions that they do have are the Move J, Move L, and Move P. These 3, I will have a video of them too in the next class, explaining how more specific how they are and what they do. But they're nothing more a way for you to move towards an object. If you gotta move to an object and it's clear, you can most of the time move J. If you have to move in 90 degrees or linearly and then don't touch nothing on the side, you'll choose Move L, and that's how I do. And Move P, you make it in combination with Move S, and that will make circles and things like that. So those are the type of motion that you're going to choose. beside the type of motion that you're going to move. So now you're telling the robot, I want you to use this motion, but I want you to go to that location. So the waypoints are actually the locations that you are assigning him to do. So every step or everywhere you want it to go, you got to tell him how he needs to move towards that. And how you do that is simple by selecting the waypoint. Once you select the waypoint, you're going to have the screen is going to change. The right screen is going to change. You're going to click select. And then, as you can see with the buttons on the positions will activate. That means that you can move the robot wherever you want to move it to. Because this is a simulator, and I was in a test simulator, I can only move it to left and right. So that's all I got. It was like, that's more than enough. You don't need no more. So, but if you are actually in a factory and you need to program it, all of these buttons will activate for you because you're just moving the arms to where you want it to go. Now, a second way of doing that movement is by clicking a certain button on the teaching pendant. But before we go there, when you put the robot in the position you want it with the arrows, you got to click OK, because if you don't do it, it's not going to remember that position. You're going to think that you'll be programming, and then you go back to your program, there's nothing in the tree. So click OK for it to accept it. And now you got one waypoint. Now, like I said, there's another way of doing it, and that is on the back of the teaching pendant, there's a button that you can hold down. They call it the free drive button. If you hold that button down, you can move the robot faster around just with your hands. You don't need to go through the pendant, but that's kind of like an override button for that movement. Now, as Peter was saying before, and you need a safety feature. These robots, the universal ones specifically, they have a unique feature on it, and that is if the robot itself is experiencing resistance, or if it's running into an obstacle, because they do have sensors on them too. If they run into an obstacle, it triggers a protective stop for them. This is one of the safety features that you can do, and it will stop the robot itself. A message will appear on the screen, and it will tell you that, yes, we do have a protective stop, and this is the code, and suggestion what you can do, and whatever you need to be doing with it. What you got to do once you have one of these is the first thing you got to do, you got to take everything around that arm, you got to take away, because otherwise the robot won't start no more. So you got to clear the area around it. Once you clear the area around it and you make sure that nobody is standing in the way and looking around and acting up, you click the enable button. Once you click the enable button, you're telling him that, okay, cool, I agree. We don't clear it out, and you can see too that the system went from yellow to green. That means that he is ready to keep on doing what he's supposed to be doing. And what you do then is just you press play. And then the robot will keep doing what it was doing. It will go back to its program and keep on moving how it was doing. Now, sometimes, that was the first video, sometimes you do have that certain situations that the robot done hit something so hard that it kind of jammed. In those parts, majority of the time with the universal ones, you can reset it. You can reboot it. It will take a little time, but that will be best for it. Or what you can do is helping him by pressing that free drive button on the back and move it into a position that it was before, and then take that error from the screen and restart it. 9 of the 10 times that'll help, but if that don't, you have to reboot the machines. Any questions about this movie? Nope. something?
No.
The next one is the last one, and then we're done. So now in this video, we're gonna have it how to prepare simple pick and place test in the in with a robot. And to do so, we will have to have an end effector. And in this case, in this situation, we're gonna use a gripper. Um, of course, you're gonna have to use the control box and the teaching pendant. Now, for a regular pick and place, the picture's gonna come up. We're gonna use an example for this is gonna be our setup. So we're gonna have a left conveyor belt that we're gonna have a product coming in, and we wanna have to pick that product up and turn it around and put it on the right conveyor belt in a box that will be rolling onto that conveyor. Now, to do so, the robot got to know when to stop and start the conveyor belt. Now, the first thing we got to do is, if we want him to be able to pick up that product, we got to put a gripper on it. So let's see how we connect the gripper and then how we activate the gripper, because it's not just connecting it that will be working. You really got to activate it too. Now, once you put the gripper on, you can see that there's a tug over here. You got to take it off to connect the cable of the gripper. Now, that cap is actually a connector that supports digital and digital input and outputs, analog inputs, and serial communications for any gripper, any type of gripper that you put on it. So that's what it will do. Now, once you put the gripper on, the first thing you got to do, and that will be best when you're programming, is changing that input name into the gripper, so you know that you're working with that gripper and not going only by locations, because a lot of times when you're programming, you tend to put addresses wrong and things like that. But if you have a name towards it, that will be best. So for that, you're going to go to installation, which is up here. You're going to click on installation and then go to the IO setup. This screen will be explained to further down in the centering and connection, because that's in the next class. I'm gonna do that, because that's actually with the weight calculating and things like that. It depends on grippers that you're using too. So like I say, you're gonna click IO setup, and then you can see on the screen that it actually have a left inputs and right are the outputs. Now, for grippers and things that you connect on it, it will always be in the middle over here. That's the tooling, that's the tools that you're going to be putting on. Now, for our gripper, we're going to use the tool output, because that's something that you're going to give out for him to do, and you're going to rename it. So you select it, we call it gripper, and then we can either press enter or just click somewhere, and it will accept it. Now, to turn the gripper on, now you select the grip. Now you connected the gripper, but then to turn the gripper on, we go to the IO, and we're gonna give the gripper power. Now, this screen too, later down the road, when we're programming and putting more external connectors and sensors and things like that, this is just for digital, like you can see, digital inputs, digital outputs, analog power up, and tools, and all those things are going to be explained later down the road. But for just activating the gripper right now, we're going to use this box, because that's going to be powering our gripper with 24 voltage, because this gripper uses 24 voltage, so we're going to just slide it to 24, and then with this button right here, you can test the gripper. If you select it, if you press it on and off, it will open and close your gripper too. Okay, so now our gripper is connected, our gripper is renamed, and our gripper is powered up. So those are the things that you don't got now. You don't install, rename, and power up your tool that you're going to use on your robot. Now, like I said before, what we're going to do is we want to transfer that product, but we got to let the robot know that, okay, cool, there's a product waiting for you to be picked up. And for that, we're going to add a sensor to it. We're going to put a sensor on the line. Now, by putting that sensor on the line, you're just going to let him know that, okay, cool, there's a product here. You need to start the conveyor. You need to stop the conveyor and then do what you got to do. For that, we got to connect your sensor and your conveyor because he needs to tell the conveyor to start and to stop. So the conveyor, we're going to connect it on the digital output 0 in the control box. And then we're going to get the sensor 1, and that's going to be in the digital input 0 of our control box. Again, like I said before, we're going to go back to our screen to rename these because we just want to know, make it sure that, okay, cool, we're using the right sensor and the right conveyor to direct. So you go to the installation, you go back to the installation, IO setup again, and then we're going to go to the input, digital input 0, and that's what we're going to rename it into sensor because that's where we put our sensor 1. And then we're going to go to the digital output 0, and we're going to rename that to our conveyor 1. So in other words, now we don't connect an external component and we don't rename them. And now whenever a box or product comes to that sensor, it will stop the line and the robot will know that he needs to drop down to pick it up. And mind you, we're just doing the external parts of the robot before we even get to the programming because all these needs to be done before you get to the programming part. Now for the dropping part of the product, we're going to put another sensor on the second conveyor and we will connect these two in the control box for him to know that, okay, cool, you got to wait until a box come there, then you can put it down. And just like we did the sensor and the conveyor 1, we're going to connect the conveyor 2 and the sensor 2. This time using digital output 1 for conveyor 2 and digital input 1 for sensor 2. And then we will go back to the installation screen and rename these. So for the sensor, we're going to go to digital input 1. We're going to call this sensor 2. And for the conveyor, we're going to go to digital output 1 and rename that as a conveyor number 2. So now the robot will know when to pick up, when to drop, and when to stop or start your conveyors. And that is actually the first part of the robotics class. We have now gone through the basics actually of setting up and pick and place a task. In the next classes, we will go over the setting of the gripper itself because, like I said before, you got different grippers, different sizes, and they have weights on them too. So you will need to calculate them and to put the exact measurements and positioning and movements for it. And then we will be ready to actually do more programming part of the robots, and then with more safety actions too, whenever you have to install one and put them in the safety area to protect it and make sure that it don't hurt anybody around it and that it is safe for the robot itself to work in it too. If you guys don't have any questions, I think that will be it for the that will be it for the presentation.
Very nice, Shanita.
Thank you for your time.
Thank you, Shanita. That was definitely a good presentation.
Oh, thank you.
Yeah,
lot of good info.
I just want, yeah, I just want to add because like when it was once we start talking about sensors, because sometimes they trying to mix the sensors for the product or for whatever you're using, and that's and in that case they're using mixing their controllers. So like adding, for example, Allen Bradley stuff to Fennec or whatever robot you're using. So and it's and nowadays it's kind of a little bit the problem because trying to make them work together so it gives a little bit inconvenient or just you need to sometimes edit separate OPC servers or something like this. So it's our reality. So the industry is still developing, but we have some problems.
Yes, that's something
And
they definitely gonna keep having, and it's gonna be even worse because all these brands are making their own
Right.
stuff, and you can see it too. I mean, look at the robots itself. You got three. You can say the same thing, but they name it differently, and then they come with sensors that work a little differently than each other, and then when you want to connect them to certain machinery that you have, and the communication won't go as normal because everybody thinks that, oh no, I got the best sensor, I'm going to make the best sensor, I'm doing this way, and it's going to work better. But whenever you want to integrate them and connect and have a communication between them, there's something going wrong, and that's where the problem is.
Yeah, I mean, every project that I've worked on that's been a packaging line that's had a robot at the end of it, that's been the problem, has been the final integration because of all the different vendors that are involved. And then the other kink to this that's being added is the vision aspect of it too. So it's just become kind of a nightmare. I mean, the last project I did where it was an integrated packaging line with a robot, we spent weeks trying to get everything down the line into a position where the robot could pick it and put it onto the pallet. And then once it got on the pallet, there was a vision system that recognized, that it was stacked in the right configuration and that the labels were all on, and we had to coordinate that too. So it's definitely a big problem, but that also presents a really good opportunity for integrators such as ourselves to kind of step in and help with all that because it is a lot of different technologies and you have a moving robot involved too. So
That's true.
yeah, correct. Because more they become flexible, more problems they pull in with them. So
Yeah.
the
The flexible is nothing more than a renaming of more problems, Peter.
yeah, but I think they developing anyway in this way because this is the no chance to go back. So that's why they right now there is a lot of systems, a lot of philosophies and theories. Everybody starts trying to develop their way and prove that their way is best than the other one. But I mean, you probably need maybe 10 more years before they get to go to the some consistent standard or something like that. So somebody will win and made a lot of money.
One day.
Yeah.
Any more questions, remarks, guys?
Nope.
no, just let me know, Shanian, when this thing it should send you an email when you stop recording, and then if you can just send me a link to it, then I can post it on the LMS.
Yes, sir.
Look at it.